Hello and welcome to another Reigate Maths video. This is Simon, and today in this video we are talking about the forces section from the mechanics second year A-level maths. So this video is going to be looking at one of the more difficult applications of forces, ladder type problems. What we do today in this video you can replicate to be rod problems as well, but it's typically something along the lines of a thing leaning up against a wall. Something like this diagram here. So in this case, we have a ladder of mass m and length 3a. The load on the ladder is at point C, which is a third along the way, and the mass is 2m of that load. It's resting on rough ground and against a smooth wall. It's in limiting equilibrium, and what we are trying to do is find, for at least part A, is find the coefficient of friction. The thing with these problems is they're a combination of a couple of topics. Clearly, because we're talking about masses, and there's going to be some forces in there. But it's also from you can apply moments to this problem in order to solve it. So this is a combination of both a forces question and a moments question. Effectively what we're going to do is we're going to resolve moments and resolve forces at various different places. First things first though, let's label the diagram and put all the forces on that we know. So first off, we have, let's do the easy ones. So we know the ladder has mass m and the load has mass 2m. So we have a weight on the load. So this could be a bucket or a person, whatever. They could make it a little bit more descriptive in the exam. We're just choosing not to. Mass times g, the weight of this load is 2mg. Now the ladder we're saying is uniform. It's not necessarily going to be uniform. All that's going to do is put the center of mass in a different place. But this, for the sake of argument, we're going to say it's uniform, which means the mass of the ladder goes in the middle. Now just to make it easy for ourselves, let's label this distance. Doesn't have to be neat, don't forget. The diagram, unless you're told to draw a diagram, the diagram is just for you. And in all likelihood with things like this, we're going to probably be given the diagram. So what else can we put on? Well, let's think about at A. Well, it's something resting, so it has a reaction force. I'm going to call it RA, so we have a reaction at A, because at B we also have a reaction force. Key thing here, reaction forces are perpendicular to the plane that they're on. So the reaction force at B is perpendicular to B, not to the ladder. The last thing we have is we're told to find the coefficient of friction and the fact that it's rough ground, so there is friction. The difficult thing is figuring out which direction the friction is going to go in. And you've got to think, okay, if this ladder were to slide, which direction would it slide? Well, it would slide down the wall and along the floor. So the ladder would move this way, which means friction goes this way. So we have friction as well. So we've got a bunch of forces. So let's resolve them. This is very typical of the first thing you do with a ladder type question, is you resolve forces. Now this method does have a lot of steps, so I'm going to label them as we go. Everything I write in green, like this, is not what you'd specifically write in the exam. It's to help. So let's resolve forces vertically. So if we resolve forces vertically, we have RA is the only force going up, and we have 3mg going down. So we know the reaction force at A is mg plus 2mg, so 3mg. Okay, so just for now, I'm going to label that equation 1 so I can refer to it later. Let's resolve forces horizontally. And we only have 2 forces. We know this thing's in equilibrium because it's not moving. So we only have 2 forces going horizontally. We've got RB and this friction. So I'm going to call that equation 2 so I can refer to it later. Okay, and we resolved some forces. Yes, there's a lot more we could do with them, but let's hold fire for now. So the next thing we're going to do is we're going to resolve moments. Now, you can take moments about any point, but pick the point that has the most forces in. Why? Because it means we don't have to worry about them. If we look back at our diagram here, we can see A has the most forces. So we're going to resolve moments about A. So we ignore the 2 forces acting at A, and we've got to consider the 3 forces otherwise. Now this is where things get a little tricky, is figuring out the perpendicular distances. So what you need to do is think about, let's see this one first. So let's first off think about the clockwise and anti-clockwise moments. So these 2 forces are going to cause a moment clockwise. I'm going to do this in a different colour. These are going to cause a moment clockwise because they are going down. The RB is going to cause a moment anti-clockwise. What we need to figure out is the perpendicular distance from this force, from the line of this force to the point. So if we keep going this way for these 2 downward forces, we can see we've got some perpendicular distances here. Okay, now we can see this in this triangle here. The hypotenuse is A. The base is what we're trying to find. So all we need to think about is trigonometry. So this length, this distance here is going to be A cos 60. Likewise here, this distance, we've got 3 over 2A, or 1.5A, cos 60, because it's the same, it's a similar triangle. So we know our clockwise moments. We know that 2mg times A cos 60 plus mg times 3 over 2 A cos 60 is, or are, the clockwise moments. So that's going to be equal to something involving RB. So RB, if we look, this is the line of the force here. So the perpendicular distance from this force to the point A is this distance here. Which is the same as this distance here. This is 3A, because the whole hypotenuse is 3A, the angle is 60, this is 3A sine 60. So we go back to here, and we know that we now have RB times 3A sine 60. We've now resolved moments, so let's do some simplifying. If we look and see with this, we can already start to cancel out some bits, and we can simplify this whole left-hand side. So we can cancel out all the A's, so let's do that to start off with, and you can see here we've got 2mg cos 60 and 3 over 2 mg cos 60. So putting this together we get 3.5 mg cos 60 equals RB times 3 sine 60. We've now got rid of one of our variables, A. Now this is where paying attention to what we want to find is important. We want to find the coefficient of friction. So we need to get friction in this equation here. We can see we know a relationship between friction and RB. So we can put that in here. We know that the friction is the same as RB, so friction is going to be equal to 3.5 mg cos 60 over 3 sine 60. Now I'm aware this is a bit of a mess, but hopefully in a bit things are going to simplify and cancel out. So this is kind of now our step 3, is actually answering the question. So what equation has the coefficient of friction in? Well, friction equals mu r. Being careful, where was the friction happening? It was happening at A. So friction equals mu times RA. But look, we've got that here. So we know that friction is mu times RA. So friction is 3 mg times mu. We then also know that the friction here is granted a bit of a mess, but at least we have it. Yes, I could simplify this to cot 60 or something like that, but there's no need. Rearranging now to get mu, we can see the mg's are going to cancel. We get mu is 3.5 cos 60 over 9 sine 60, which we then work out using our calculator. Typing it in, our calculator will probably give it to us as a surd, because we've got sort of nicer trig functions here, but we need to have it as a decimal. And typical degree of accuracy should be 3 significant figures. So this is kind of the process for it. For these type of questions, it's resolve forces and resolve moments. Doesn't matter hugely the order you do it in. I tend to do it this way because resolving forces tends to be easier. Key things with getting all the marks in the exam: make sure you're clear which direction you're resolving in. So you might even want to write this resolve forces, resolve moments about A, to make it really clear to the examiner what you're doing. Don't feel you have to number your equations. I did so that when I was talking about them, I could have referred to them as 1, 2, and 3. Additional things we could do with this, we might have questions about our assumptions. So we might have a question that says, state how you have used the assumption that the ladder is uniform in your calculation. Answer would be something along the lines of, the center of mass acts in the middle, or acts at the center, or acts halfway along the ladder, something along those lines. And any of the assumption questions you could have like that. These questions tend to throw students because there's lots of steps, or there's lots of chances for you to make a mistake. But the thing is, as long as you pay attention to your perpendicular distances, which forces are going where, and your formulae, these can be very nice questions because they're very formulaic. And of course, label your diagram. Thanks for watching.